Hi, in this video we are going to see about yet another disk scheduling algorithm, that is scan scheduling. So in case of your scan scheduling, the disk arm starts at one end of the disk and move towards the other end, servicing the request. The head continuously scans back and forth across the disk. So the scan algorithm is also called as elevator algorithm. So the main advantage of your scan algorithm is that it has the high throughput, and the main limitation of your scan algorithm is that the request arriving just behind the head will have to wait until the arm moves to the end of the disk. For example, what this particular statement states that here you will be having a head position. So here in this example, your 53 is the head position. Okay, so whichever is arriving just behind this head position, for example 65 is arriving just behind the head position. Okay, this 65, it needs to wait unless the arm moves to the end. Okay, until the arm moves to the end, this 65 needs to wait. Okay, that's what this one means. So in case of your scan scheduling algorithm, the main thing is that in case of your FCFS and your SSTF, you will be having the current head position. But apart from current head position, in case of your scan algorithm, you need to know one more thing, that is the direction of the head movement. If it is given as towards 0, then it has to take the request that is moving towards 0 and it has to service that request first. Okay, if it, for example, if it is given towards 199, then whatever request that is towards 199, that must be taken first and it should be serviced, and then only it has to move to the next end. Okay, that's what this thing means. Okay, so we will see one example, and we will come to know how that scan scheduling works. Okay, so let us take an example. So in this, if we see, I have a disk that contains 200 tracks that ranges from 0 to 199, and I have a disk queue of request. It is given here, and then I have a current head position. It is at 53, and I told you need one more information. It is given that the disk arm is moving towards 0. What that means? That means whatever request that is before your 53. Okay, whatever is there, what are all the requests that are there before 53. Okay, your head is at 53. Before 53, whichever is there, that request must be serviced first. Okay, so we'll be taking the requests that are less than 53 and we will service that first. Okay, so these are the requests which we have. In that, 37 is the request that is coming in first. Okay, this 37 is smaller than 53 and it must be serviced first because your disk arm is moving towards 0. Okay, so 53 to 37, and then your 14 comes, then the request 14 comes, so 37 to 14. So here if you see, you need to note one more point, that is, once it reach 14, you should not move back and service 65. Okay, so what it has to do is, it has to go till 0. Okay, towards 0. I have given it as towards 0, so it has to reach up to 0. Okay, so from 14 it is reaching up to 0 and checking it out whether any other request is there in between 14 and 0. Okay, no more request is there and it has reached 0. Right now it is in 0. Okay, what is my next request? My next request is 65. Okay, so now your 65 will be serviced, and then 67, 98, 122, 124 and 183. That is how it will be done. Okay, so once this is done, we need to find the total head movements. Okay, so for total head movements, I have given one way of calculation in my FCFS and SSTF video, and this is another way of calculating your total head movement. Okay, so here if you see, it goes from 53 to 0. So 53 minus 0 plus, it is going up to 183, from 0 to 183. So 183 minus 0, so it will be 53 plus 183, that is 236. Okay, so once again I repeat, it is going from 53 to 0, so I am taking it as 53 minus 0, plus from 0 it is going to 183, that is 183 minus 0. So when we do it, it is 236. So the total head movement here is 236 cylinders. Okay, so this is your way in which the scan scheduling works. Okay, if you have any doubts, you can just comment on it. Thank you.